Hello guys, welcome back. In today's lecture, let me open the notepad. We will be discussing more about the next principle of microservices as we discussed in detail in our last lecture two of the principles designs for failure and decentralization data management. Apart from that, today we will be discussing about the infrastructure automation, which is very much important principle for the microservices. Basically, what the infrastructure automation is like, without manual actions, things should happen itself. We can say this is the automation, and for this, basically, it helps us to learn how your code in your local machine goes to microservices that are running in AWS environment. This is what infrastructure management is. Basically, this is part of code maintenance, software management, and like this entire environment. And this is how we can do it using CI CD, which means nothing but continuous integration and continuous deployment. What does it mean? Like, continuous integration means you are writing the code and continuously you are working on its deployment as well. We will be having some of the tools here, like GitHub, Bitbucket, that helps us to work in this manner, as Jenkins, or we can say scripting as well. So with the help of these tools, like when you put your code in central version system, here these are the central version system or central version control, because let me write over here, like git, because whenever you write a code or you integrate it with the git account, then this particular code will be visible to whole of the members of your team. And again, with the help of those changes that you had made or your team members have made, with the help of this conversation and this sync, we will be able to work on it further without any crash. Now, once you put your code in the central version control system like Git, your code will be compiled over here. Will be compiled, and if it success or if it succeed, then you will take the jar file and deploy in your AWS server. But if it failed, then you will get a notification, a mail, or whatever, how you will get notified that this compilation has some issue and it is not compiled well. So, in this way, if it is success, you will take the jar and you will deploy it in AWS. For this purpose, we must have the deployment DevOps, we can say, and this is the development operation team. Basically, when we work in our team, like, generally there is one particular DevOps for a team of 20 members, so that these kind of work can be done within their investigation team. Like whenever there are DevOps, they will be working on these kinds of work. So if, like, this is for one particular microservices, if we have 50 such microservices, then we need to do the same thing for all those 50 microservices, and this is the work that needs to be done by the DevOps team. So, whenever we are working on these projects to have the continuous integration and continuous deployment, we must have one DevOps for a particular team of, let's say, a 20 members team, so that all these work of deployment can be done by the development operation. And apart from that, we must be very much clear that microservices are designed for scale. Let me tell you how and what does it mean, like how microservices are designed for scale. Let me tell you here. Yeah. So, yeah, over here. For this, what does it mean? See, when we are saying microservices are work designed for scale. It means sometimes we have this service and we have multiple users over here. Then what we do, we will increase the number of services in this particular case. So this is scale up. This is what we call as scale up. And in the reverse way, when we need to reduce the size, then it is scale down. Apart from that, we have the word as vertical scaling and horizontal scaling. For vertical scaling, it only means like when we have a service, like this is a service, let's say it is for data of 2 core and increasing their size. Like we are having another service and it's having 4 core and increasing it further for 16 core data. So this is the vertical scaling, but this vertical scaling has some limits. It cannot increase infinitely. So for that purpose, we have not only for that purpose, but not only for that particular purpose, I will say apart from that, we have horizontal scaling, which is the best practice to work upon. In this, what it do, basically, whenever there is rush, we have multiple services of same size basically, and same thing can be done with this as well. Once we limit the size of this particular service, then we will increase the number of services of that particular limit only. Here we have rush, then we can use the multiple services, and this is what we call as horizontal scaling. Like we have add more machine to one load. So there are three different machines. We can say here the size is same. Let's say it is of 2 core. The same will be, let me copy. Same will be here and same will be here. So all of these three are of same size. And this is what we call as horizontal scaling, because vertical scaling cannot do infinitely, but horizontal scaling can do infinitely. You can increase as many number of services as you want. So this is the best practice to go with. Apart from that, as these are the scaling, scale up, scale down, vertical scaling and horizontal scaling, we want our infrastructure to be an automation. What does it mean? We must want auto scaling. How it can be achieved? In AWS, we have ASG, which is auto scale group, that is utilized for this purpose, and it has some configuration, and these are the configuration that we need to set while working. So whatever configurations we want, we can fix those configuration, and then we can further start working on it. So this is what we call the scaling and the infrastructure automation while working on the microservices. Apart from that, let's move further to work upon how one of the microservices can connect to the another microservices. So the next topic that I'll be discussing is, I'll start with the a question. For that, I will say we want to answer how one microservice connects with the other microservice. For that purpose, we have basically there are two approaches. For this purpose, there are two approaches. I'll explain both of these in detail. We have two approaches. One is load balancer, and the second one is service registry. For this, let me explain it one by one. When one of the microservice, let's explain it through the diagram itself. When one of the microservice here, it wants to connect with another microservice over here. So let me represent as microservice 1, and here we have microservice 2. Whenever they want to connect, then in between this there will be a load balancer. We can represent it here. Let's represent it with this way, and name it as load balancer. So what does it mean? Basically, when one microservice called the load balancer, it determines the right server on the destination, as there are multiple servers available. uh, Let me represent it in this way. Here this is the server, this is the another server, and here we have the another server. So as there are multiple servers, the load balancer will connect with these server. Once a micro server here, once there is a microservice that will connect to the load balancer, or it will call the load balancer, then it will determine the right server, whatever we want to connect with. So it may go with this, it may go with this, or it may go with this. Once it will select the correct server on the destination, then this particular server will connect with the microservices too. So this is the way how we can connect one of the microservice to another microserver, and this is the first approach. Let me write over here as well. So this is the first approach to connect, and the second one is using the service registry. How it work, let me show you. So again, this is the not this one. Here again, this is the microserver again, and this is the another microservice. Here we have, let me write microservice 1, and this is the another service, microservice 2, and here in between this we have the service registry. Let me write over here, this is the service registry And how does it work? Here we have the different servers as we uh, used earlier as well. So here we have different servers connecting. So these are the server that are here. Let me write the service registry we will be working here. Eureka server. Basically all these servers need to register themselves to this service registry whenever they want to connect with. So once they will register, whenever this service registry will get a call, then all the data that they are getting from these servers, then it will check whichever is suitable. All of these servers, they will get register themselves to this service registry. When one microservice wants to call another microservice, here this will look up from the service registry that what server we should connect with, and then only we can approach to the microservice too. So this is how it will basically look for the best server available. This is how it works. And this is we can even say this part as the client side load balancer, because this all been registered over here itself only. So this is how it works. This is how we can connect the one service to another, and this is the second approach. Now again, whenever like apart from that, we can have the system like whenever there is a client. Let me represent here. Whenever here is a client, and here again we have the same service. Let me copy over here the same thing that I want to copy. Let me paste. All these things are already available over here. Let me enclose it. Yeah. So whenever there is a client and this client want to connect with one of the microservices, for that here we will be having in between this, we will be having the load balancer again over here. This is the load balancer, or even we can use API gateways for this purpose to connect from the client to these services. So this is the load balancer. Now let me tell you how this load balancer will work. They will just connect through the this load balancer will connect through the DNS, which is domain network system. And this is how we can have multiple DNS example we can take. We have GoDaddy, we have Namecheap, and we have Cloudflare. So what they basically do is they just do the domain mapping. They do the domain mapping and they just map to the load balancer IP, and this is they will get configured. Basically this load balancer is having less feature, so if we want more features then we'll connect through the API gateways. So this is how this load balancer will help the client to get connect to these services. So it will be connected through the load balancer itself. So this is all that I want to discuss you all with the principle of the microservices and how these services will get connected. And apart from that, I want to let you know about one of the security rule from the AWS, which is WAF, which is even known as Web Application Firewall. It is nothing but is the rules for security, because we are working with APIs. Sometimes it is there are lot many hackers. To avoid such situation of getting it hacked, the APIs to get hacked, the AWS is providing us WAF, which is Web Application Firewall rules for the security. And here same API can't be called by the hackers. So we can protect our project using this application of AWS, that is WAP, that is Web Application Firewall. Now, apart from that, let's discuss and move on to the next topic of today, where we will be discussing about the uh, properties. Let me open the ID as well. Just wait for a few seconds. How, as we discussed earlier as well, we have different environments. We have local, AWS, QA, UAT, production environment. So whenever we are working on one of the environment, our whole project should run in that particular environment only. We cannot move from one environment to another. Let's say, let me show you with an example as well. Suppose here we have, this is one environment, and let's say this is the another environment. Here we have the three services. Let's say uh, this is the second service, and here we have the third service, and same thing we have for the second system as well. Let me write here as the, let it be the local environment, and same thing here we have for the AWS environment. Now, all of these microservices, they have their own IPs. It will be having its own IP, it will be having its own IP. And same thing will be here as well. We cannot work on like whenever, here we have six different IP. Let me write as IP1. Here I will write IP1 dash, and here I will write IP1 double dash. And similarly, for this I must write IP2, and here I must write IP2 dash, and this is IP2 double dash. So we can connect this microservice to this IP only. If we want the microservice this to connect with this is not possible. This should not be done, because here we are dealing with two different environments, not the same one. So whenever we want to connect the microservices, we must, whenever we are discussing or talking about, all of these must be in the same environment only. For that, let me discuss one of the question here. Again, I will be discussing with the terms of question itself, how to have environment specific configuration. For that purpose, we have a Java code in our ID and want to execute to different environment. For that, basically, there is profile that allows us to run our Spring Boot application in different modes. Basically, two versions of configuration profile we have as one is, it must be like application local dot properties, and the second one we have is application hyphen local dot YAML. So these are the two versions of configuration profile that might have, and both of these have different writing way. Like let me show you. Let's use chat gpt for this. uh, Let me write over here how we can uh, way to write key value pair in both way and compare. So this is how we can take the help of ChatGPT. So this is application-local.properties, and this is for your YAML. Like here is like server, then port, then this is key and value pair. This is how it works. But in this case, we have key is equal to the value. Key is equal to the value. So it will be the same, but in this case, it will be in that particular manner. So this is how, like, they will be flat key value pair, but here it will be structured or hierarchical way to represent. Like here we can say we have app.name is equal to test app, but here we will be right in this particular way. So this is the difference that we have within two versions of configuration profile. So this can be seen within the application properties. Let me show you here in resources. Here we have the application properties. Here we have spring.profile.active, spring.application name, which is the provider service. So this is the main application property, and this is common for all. It is not the environment specific property, but apart from that, I have created some more environment specific properties as well. Let me show you here. So uh, let me show you. Yeah, here we can see. So this is what we have is the local property. This is for the local environment itself. So whenever we want to active or we want to activate one of the profile, we must write like over here we must write spring.profile.active is equal to local or is equal to whatever. Let me write it over here. To activate one of the profile, we must write this is equal to local, or this is equal to dev, or whatever we want, whichever the profile we want to get activated. And whenever we want to take the or want to read the value from the properties file, we must use the annotation at the rate value. It will help to read the values from the properties file. Basically, whatever are the values that may change in future, these are the values that are not constant. We won't use it in our code itself. We will rather place it in the application property. Whatever value, like the server port, that we can change in future. So these terms are not fixed, so this can be used or can be written in the application property, that can be changed later. We can say the password as well, or the emails. We can say we want to send some of the notification to multiple email IDs. These emails cannot be a fixed part of the code, because it will be changing. We will be sending the same, although the message is constant, message is not getting changed, but the user, but the receiver, we can say, are getting changed. So those type of application which can change in future, that must be kept under application.properties, that can be changed in future and it is not constant. And to read these value, we must use at the rate value in our code, and it will help us to read the value from the properties files. And when we want to, it will only read the value. If we want to print those value, we must write at the rate post construct and public void int, and here we must write log.info, whatever output or whatever way we want it to be presented here, or whatever, uh, like whatever value or key we have, value for that particular key we have. Here is the value of the key. So this is how we can get the uh, value to be printed. So this is how we want get the value to be printed. It is basically, I have, yeah. So this is how we get the value to be printed from the application.properties file. So this is how we can have the environment specific configuration whenever, whatever environment, let me write over here, whatever environment we want to work upon, and it should be same for the whole project. We cannot deal with one of the service from one environment and other from other environment. All the services must be in the same environment to work with. So this is all, and this is how we have learned about the principles of microservices as infrastructure automation, and how to have environment specific configuration, and how one microservice can connect to the other microservices. So this is all, hope you understand it well. Thank you.